problem that for some reason I went into complete brain lock on figuring it out. Or I think it was more I was overthinking this. Yes. Now, whenever we start looking at these, cosine and arctan, or arc cosine, these inverse and cosine, where they're not really matching up, and they're not nice. Because arc tangent of -3/4 is not a nice one. And what I mean by nice is saying arc tangent of the square root of 3, which doesn't seem like a nice number because the square root of 3 is not a rational number, but it is on the unit circle. Because we can look and see which value arctangent would be for the square root of 3. And it does give us a nice kind of angle. The calculator can give us a nice angle for that. Because those are following our 30, 60, 90 kind of angles. The pi over 3, pi over 4, and pi over 6. So they're kind of nice, even though it's not a nice number. But for these here, what we can do is set up a triangle for it. Now, tangent inverse. The inverse of tangent, what we're really talking about for this in here is what value tangent of what angle is going to give me the value of -3/4. Because this is the reason we use inverse. Because we're trying to get the angle out of tangent, sine, or cosine so we can figure out what it is. So if I took tangent inverse of tangent of u, we would get back to kind of our arctangent of -3/4. That's kind of the goal. And as we talked yesterday at the start of the lesson, we said tangents, angles, are restricted between -pi/2 and pi/2. Those are the values we can get out of this. So looking kind of on a unit circle, well, this is 0, this is pi/2, this is -pi/2. So for tangent, we have to either be in the first quadrant or the fourth quadrant. These are the two quadrants it can be. In tangents, what? Negative. Equals negative angle, or negative value. Well, the only spots it's negative out of these two is in the fourth quadrant. The only other place tangent is negative is in the second, but we don't have an inverse for that value. It doesn't work for that value. So it's going to be in one of these two here, which means our triangle, if we set it up in the quadrants, would be down in quadrant 4, which tells us, again, tangent is opposite over adjacent. So the opposite side would be 3, our adjacent side would be 4, because our angle's right here, yes? Now, and again, this is kind of where I went back and forth and ended up giving y'all two answers, is applying the negative. Because just saying -3/4, well, the 3 could be negative or the 4. One of them could be negative, yes? And it's kind of going through how do we determine which one's negative. This picture answers that question for us. We don't have to do anything with it. Because if I look at the sides of that triangle, which one's going a negative direction? The 4 or the 3? The 3, yes? Because if we go down past the x-axis, that's our negative. It answered it for us. We didn't have to figure out which one's going to be negative because we set it up in the correct quadrant. This is also why, especially when we're dealing with find the 6 trigonometric values for a given point on the axis, I plot that point because it helps tell me which one is going to be positive, which one's going to be negative. Because we just think of the x-axis and y-axis, which side's positive, which side's negative, and it'll tell me outright. And even on the ones that just say tangent of theta is equal to 3/4 where sine's greater than 0, I'll plot it so that I can see which one's positive, which one's negative, and it'll tell me. I don't have to go through and memorize, okay, if it's in this situation, this one's going to be positive, this one's negative. Or if it's in this one going on that way, I can plot it and see it. So it's telling us the 3 is going to be negative, yes? And again, we're just trying to find this here is just u, yes? Our angle. This arctangent -3/4 is telling us u is equal to arctan of Negative 3/4. We just want that angle, yes? Well, I'm going to replace this arctan with Jim. Or in this case, this is our angle U. As we have it set up, that's the angle. Yes? What is cosine? Adjacent over hypotenuse. So we just need to find the hypotenuse, which is 5. 3, 4, 5 right triangle. So cosine of U, cosine of this angle, is adjacent over the hypotenuse. So it's 4/5. So really, once we get the triangle set up, we can solve it from there. So the inverse pretty much gives us the setup for the triangle. Then we can use that triangle to find cosine's value. Questions on this here? So we were looking at, make sure it's in radians, cosine of tangent inverse or arctangent of negative 3 over 4. Math, enter. And it gave us the answer anyways. So a lot of these, it'll give us the answer for it, which is kind of nice. Any other questions on this one here? So cosine of arcsine of negative 3/5. So we can see here cosine of sine inverse of negative 3 over 5.8. Or 4/5. Okay? And we can work this one out here. Now for cosine, or for sine inverse, if we looked at the picture and we wanted to do this by hand, again, sine inverse is angles are restricted between negative pi over 2 and pi over 2. Negative 90 and 90. Between here and here. And in the first quadrant, sine's value is positive. In the fourth quadrant, sine is negative. So it's telling us that our angle that we get from this, we can call it U or we can call it theta, either one, is going to be down here. That really we can say from this, because this is saying U is equal to sine inverse of negative 3/5, is the same as sine of U is equal to negative 3/5. Because these here are going to be interchangeable. And if we look at this as sine of U, that angle is negative 3/5. So sine is what over what? Opposite over the hypotenuse. So the opposite side would be 3, and the hypotenuse would be 5. Which one's going to be negative, the 3 or the 5? It's going to be the 3. The hypotenuse is never going to be negative on any of these here. Because it's going to be our x or y, which one we're moving over and down. Going from the origin to the point, the hypotenuse, our r value is always going to be positive. What's our x value going to be? 4. They like using Pythagorean triples. So we can say that this here is cosine of U. Cosine is adjacent over the hypotenuse. So really, once we get these set up as they're triangles, they're easy to work with. Questions on this here? Do we need to see another one of these? Sine of arc cosine of 3x. So again, we're going to do the exact same thing we did. We'll set this up. Because we're going to want to set a triangle up first. Now, cosine inverse is between 0 and pi. 0 and 180. So really what we're saying for this here is that we have u is equal to arc cosine of 3x, or that cosine of u is equal to 3x. Well, the only place that cosine's positive is in the first quadrant, because cosine's going to be negative in the second quadrant. And cosine is adjacent over the hypotenuse, yes? What's the denominator going to be for this here? If there's not 1 written, it is 1. So we're saying the adjacent side is 3x, and the hypotenuse is 1. Now, we need to find the other side, which is just using Pythagorean theorem, 3x squared plus, we can call it y squared, is equal to 1 squared. Well, 3x squared is 9x squared, plus y squared is equal to 1. Now, you don't have to call it y squared. I just called it y because we're looking at the y-axis. You could have called it b. We could add b squared since it's one of the sides of the triangle. You can call it whatever you want. But we're wanting to get it by itself. So we're going to subtract 9x squared from both sides, telling us y squared is equal to 1 minus 9x squared. Take the square root of both sides. Y is equal to the square root of 1 minus 9x squared. And when we normally square root both sides, we add the plus or minus, yes? Is the y value that we're looking at positive or negative? Positive. We're going up, yes? So we don't need the plus or minus. It's just going to be positive because we're on the positive y-axis. If it had been the x-axis and it was in quadrant 2, then it would be negative. So really all I did to determine positive or negative is I looked back and determined, well, I'm trying to erase, determined which axis are we on. We're on the positive y, so it means this is going to be positive. If it had been in quadrant 4 for that same length, it would be negative. So, with all that, we can say that this here tells us that we have sine of u. Well, for sine, in our angle u here, we have opposite over the hypotenuse, yes? What's the hypotenuse? 1. And the numerator is this here, so it's just 1 minus 9x square root of 1 minus 9x squared. And that's it. We can't really simplify that any further because it's not squared. We can technically factor it because it is a difference of perfect squares, but that doesn't help us because it doesn't give us something squared. And that's it. Questions on this here? I'm not going to bore you with another one of these, but that's what I'm looking for. There we go. There's one more problem I want to look at. Let's say. this is the last problem we're going to look at. Now, I'm including this because I did include it on the homework and on the test. I realized I didn't put it in the note sheet. But what we're doing for these here is not that overly complicated. What we want to do is we want to write this here, this problem, in terms, as theta in terms of x. We want to get theta by itself and have everything on the other side be in terms of x. Now, looking at this here, so we have the adjacent side to the angle and the hypotenuse, yes? So that would be cosine. So we can say that cosine of theta is equal to adjacent side, which is x plus 4 over x squared minus 16, yes? Well, to get the angle out of here, we can take cosine inverse of both sides, because cosine inverse of cosine of theta is theta. Now we should simplify it if we can. Is the x squared minus 16 a difference of perfect squares? Yes, it would factor to what? X minus 4 and x plus 4. Well, that would give us something that matches on top and bottom, yes? So we can say theta is equal to cosine inverse of x plus 4 over x minus 4 and x plus 4. Okay. These will cancel, just telling us theta is equal to cosine inverse of 1 over, and that's it. Not too bad. I mean, it's just really setting them up and simplifying if we can. For these here, if you end up with a square root of like x plus something in the denominator, I'm not going to ask you to rationalize those. Just leave it as is. I'll take that answer. Because those, it's going to be a little more tricky and challenging to try to rationalize than it would be, say, the square root of 3. So, but that's it.